Hey there, Joel here, and welcome to my channel Math World. Today we are going to learn something from the triangles chapter which most of the students find difficult, and those are riders. And this is what the situation of the students become when they see those riders on the question paper. Okay, and I've tried to make it as simple as possible. Please watch the entire video. Do not skip looking at the figures, because most of the times students leave these questions just by looking at the figure because it looks complicated. I've tried to make it as simple as possible, so let's straight jump into it. So I have a quadrilateral PQRS, which is a rectangle. C is any point in the plane of the rectangle. Through C, a line AB is parallel to PS, meeting ray PQ and RS at A and B. Line CD is parallel to PQ, intersecting QR at D. Prove that CQ square plus CS square is equal to CP square plus CR square. And I'm sure you're already getting worried with regards to this proof. Let's break it down with a figure. So I have a rectangle. I've told you the name is PQRS. C is any point on the plane of that rectangle. That means I have a point C. Through this point C, a line AB is drawn. Okay. Now which is parallel to PS, and this PQ is extended so that it joins at point A, and RS is extended so that it joins at B. Okay, this much is very clear. Now CD is extended, or C is extended to point D such that AP is parallel to CD. Okay, now this much is given as the information in the question, but when they are proving, they are talking something about CQ. Now if you look at the figure, there is no point or no line which is joining CQ. There is nothing as CS, there is no CP, and there's no CR. So all that we have to do is join these points and it will be something like this. Okay, now since PQRS was a rectangle, I've marked 90 degrees over there. Okay, now how do we start? Let us say that since your AQ and BR are part of PQRS, that means I've extended PQ and SR so that that line is extended. Obviously AQ and BR will be parallel to each other. So let's write down that. So since AB is parallel to PS and AP is parallel to BS, and angle APS is 90 degrees. We already marked APS is 90 degrees. PQRS becomes a rectangle. We already know that, and so does AQRB. Okay, so PQRS is the smaller rectangle and AQRB is the bigger one. Second step, I can write AP is equal to BS, because we know that whenever you have a rectangle, the opposite sides of a rectangle are equal. So AP is equal to BS, and AQ is equal to BR. Step number one more. I've not written 1 over there. Let's consider that previous one as step number 1. So from that we are able to conclude this. In the next step, if you look at the figure, which is in red in color, AQC, okay, so there is a right angle over there, which makes this from Pythagoras theorem as triangle QAC will become CQ square, which is the hypotenuse, is equal to AC square plus AQ square. And this triangle, which is blue in color, CBS, for that right angle triangle it will be CS square is equal to CB square plus BS square. Again, Pythagoras theorem. In the fifth step, what we are doing is we are adding the third and the fourth step. That's the reason I've written them in two different colors, the red and the blue one. So left hand side is added and written on the left hand side, right hand side is added and written on the right hand side. So CQ square plus CS square. Now if you look at the question, what are we asked to prove? The one little half of the part is already done. CQ square plus CS square, which we want on the left hand side, is already, we are coming to that. So we have already got that as the answer. Now let us look at the right hand side. Over here, okay, I've got this by adding 3 and 4. So in this, I've marked over there, over here. So AP is equal to BS, which was written in step number 2. In step number 5, we have a side which is BS square over there. So I have replaced BS square with AP square. That's why both of those terms are highlighted. So BS square from the fifth step is replaced with AP. How did we come to know about that? From step number 2. Similarly, I have replaced AQ with BR. AQ square from fifth step is replaced with BR square in the sixth step. How did we come to know? From step number 2. I hope this part is clear. If not, just rewind the video a little bit and go ahead, watch it again. You'll be able to understand that. Okay, rest everything remains the same. Now what we have done is, in the seventh step, left hand side kept as it is, AC square plus, instead of writing BR square next, I have just rearranged those terms so that AC square plus AP square comes closer and BR square plus CB square comes closer. Okay, now why I have done it, let us understand. Okay, if you look at the figure which is turning orange over there, AP square plus AC square is equal to CP square. So that is written in the 8th step below AC square plus AP square. How did we get this? From Pythagoras theorem. Same way, what is in yellow? BR square plus CB square is equal to CR square. Again Pythagoras theorem. And what we have got till now in step number 8 is exactly what we are asked to prove. And the rider is that simple. Now the problem comes over here is that you might probably comment or send me an email asking me, so how did you know to solve all this in this manner? And I would say that comes with practice. You keep solving problems, you keep solving riders, and you will automatically, when you look at the figure, you'll get a vibe that, you know, probably I should go about in this manner to get the answer. There are no proper steps as such that, you know, I can work it out in all the riders possible. In a simpler terms, I would say there is no perfect recipe to make it. Okay, you have to keep trying, you have to innovate your steps to get these answers. Okay, I will solve a few more proofs in the upcoming videos. Go ahead, watch them as well, and probably you might get a little bit of insight in solving riders. I hope you liked this video. If you did, please don't forget to hit the like button, share the video with your friends, subscribe to the channel, hit the bell icon, and solve math a little more. Thank you very much, and please don't forget to hit that like button because it takes a really lot of efforts to put down the entire triangles and figures into this PowerPoint to make it into a video. So don't forget to hit the like button, practice these problems, write it down, solve it yourself. If you have not understood, watch the video again and enjoy solving math. God bless you. Bye bye.